What if I told you that a significant chunk of our planet's interior is missing? I know it sounds like the plot of a science fiction movie, but this is a genuine mystery that has geologists scratching their heads. We live on the Earth's crust, a paper-thin layer compared to what lies beneath. Below us is the mantle, a vast, scorching, hot sea of rock that makes up about 84% of our planet's volume. It's a dynamic, churning layer that drives everything from volcanic eruptions to the slow drift of our continents. For decades, we thought we had a pretty good handle on what the mantle was made of. We studied rocks that were pushed up to the surface, analyzed seismic waves that travel through the planet, and built sophisticated computer models. Everything seemed to fit together. The story was simple. The mantle is mostly made of a rock called peridotite, which is rich in minerals like olivine and pyroxene. This understanding became the bedrock of modern geology. But science is all about questioning, and when scientists took a closer look, they found a massive discrepancy. The story wasn't so simple after all. They realized that the composition of the mantle rocks we see on the surface, the ones that form the oceanic crust at mid-ocean ridges, don't quite match what we expect the mantle to be. There's a crucial ingredient that seems to have vanished. This is what scientists call the missing mantle paradox. Imagine you have a recipe for a giant cake. You know all the ingredients that should be in it. But when you take a slice, you find that a key ingredient, say, all the chocolate, is gone. You'd be confused, right? Where did the chocolate go? That's essentially the problem we have with the Earth's mantle. The rocks that well up from the mantle to form new crust at mid-ocean ridges are what we call depleted. They are missing certain elements, particularly what geochemists call incompatible elements. These are elements that don't fit neatly into the crystal structure of the main mantle minerals. Think of them as the awkward guests at a party who don't want to join the main group and prefer to hang out on the sidelines. When the mantle rock partially melts, these incompatible elements are the first to jump into the liquid magma. So, the magma becomes enriched with them, leaving the remaining solid rock depleted. The crust that forms from this magma is therefore enriched, and the leftover mantle is depleted. This part makes sense. But here's the kicker. The amount of depleted mantle we can account for is far, far greater than the amount of enriched crust we can find. If the continents and the oceanic crust are the enriched part, they only account for about half of the depleted mantle we observe. So where is the other half of the enriched material? It's as if the Earth cooked its crust, but then hid half of the ingredients somewhere deep inside. This imbalance is the core of the mystery. It tells us that our picture of the Earth's interior is incomplete. There's a huge reservoir of material, a hidden chemical signature that we just can't find. So, where could this missing material be? This is where the detective work really begins, and scientists have come up with some fascinating theories. One leading idea is that this missing enriched material never made it to the surface crust at all. Instead, it sank. As tectonic plates, specifically the oceanic crust, get old and cold, they become denser than the underlying mantle. Through the process of subduction, these plates plunge back down into the Earth's interior, acting like a giant conveyor belt. This subducting oceanic crust is enriched with those incompatible elements we talked about, soaked up over millions of years. Perhaps this crust doesn't just mix back into the general mantle. Instead, some theories propose that it sinks all the way down to the boundary between the mantle and the core, nearly 3,000 kilometers beneath our feet. Down there, it could accumulate over billions of years, forming distinct chemical reservoirs. Imagine ancient slabs of the ocean floor, piled up at the bottom of the mantle like a geological graveyard. These piles would be chemically different from the surrounding mantle, holding on to that missing enriched signature. We can't see them directly, of course. We're talking about pressures and temperatures that are almost unimaginable, but we have clues. How can we possibly see what's happening at the core mantle boundary? The answer lies in seismic waves. These are shock waves from earthquakes that travel through the planet. By studying how their speed and direction change, geophysicists can create a sort of CAT scan of the Earth's interior. And these scans have revealed something extraordinary. They've shown two massive continent-sized blobs of unusual material sitting right on top of the core. One is located deep beneath Africa, and the other is under the Pacific Ocean. Scientists call them large low-shear-velocity provinces, or LLVPs for short. The name simply means that seismic waves slow down significantly as they pass through these regions. This slowdown tells us that these blobs are different. They could be hotter, or have a different chemical composition, or both. Could these mysterious blobs be the missing enriched material? Are they the final resting place of countless subducted oceanic plates? The hidden reservoir we've been looking for. It's a very compelling theory. It neatly solves the paradox by providing a hiding place for all that enriched material. It suggests that the mantle isn't a single, well-mixed soup, but has distinct ancient regions that have been preserved for billions of years. But the story doesn't end there. Another fascinating theory suggests that the missing material might not be from our own planet. What if it's the remnant of another one? This idea sounds wild, but it's connected to the very birth of our moon. The leading hypothesis for the moon's formation is the giant impact hypothesis. It suggests that early in our solar system's history, a Mars-sized protoplanet, which scientists have named Theia, slammed into the young Earth. The collision was cataclysmic. It would have vaporized both Theia and a large portion of the early Earth's mantle. The debris from this impact was thrown into orbit and eventually coalesced to form our moon. Now, what happened to the rest of Theia? Most of it would have been absorbed by the much larger Earth. According to this theory, chunks of Theia's denser, iron-rich mantle didn't fully mix with Earth's mantle. Instead, they sank through the fiery ocean of magma and settled at the bottom, right on top of Earth's core. If this is true, then the two giant blobs we see with seismic waves, the LLVPs, could be the long-lost remains of Theia. They would be alien graveyards hidden deep within our own world. This theory is incredible because it connects three massive mysteries: the missing mantle, the origin of the moon, and the existence of the strange blobs at the core mantle boundary. It paints a picture of our planet's history as far more violent and complex than we ever imagined. Whether these blobs are ancient terrestrial graveyards or alien planetary remains, their presence has profound implications. They aren't just passive lumps of rock. They are actively influencing our planet today. Because they are likely hotter and less dense than the surrounding mantle, they are thought to be the source of massive plumes of hot material that rise through the mantle. These mantle plumes are like giant lava lamps. When they reach the base of the crust, they can cause massive volcanic outpourings known as hotspots. The Hawaiian Islands are a perfect example of this. The entire chain of islands and seamounts was formed as the Pacific Plate drifted over a stationary mantle plume. Other hotspots, like the one beneath Iceland or Yellowstone, are also thought to originate from these deep mantle sources, possibly connected all the way down to the LLVPs. So, this ancient hidden material isn't just a historical curiosity. It is actively shaping the surface of our planet, driving some of the most powerful geological forces we know. The very ground beneath our feet is connected to a mystery that is billions of years old and thousands of kilometers deep. The missing mantle paradox shows us that even a planet we've lived on our entire lives is still full of profound secrets. So how will we ever solve this puzzle for good? Scientists are deploying an array of amazing techniques. They are improving their seismic imaging, using networks of seismometers around the globe to create higher resolution maps of the mantle. It's like upgrading from an old blurry TV to a 4K display. We're starting to see the details of these deep structures more clearly. Geochemists are also analyzing the chemical composition of lavas from hotspot volcanoes with incredible precision. The lavas from places like Hawaii and Samoa have unique chemical fingerprints, different from the lavas at mid-ocean ridges. These fingerprints are like messages from the deep earth. By decoding them, scientists can infer the composition of their source material, providing direct clues about the nature of the LLVPs. Furthermore, powerful computer simulations are becoming more and more sophisticated. Researchers can now model the cataclysmic impact of Theia with Earth, or simulate the behavior of the mantle over billions of years to see if these theories hold up to the laws of physics. They can test whether subducted slabs would indeed pile up at the core mantle boundary, or if Theia's fragments could have survived for so long without mixing in. Each new piece of data, each refined model, brings us one step closer to understanding the true nature of our planet's interior. This is science in action, a grand detective story playing out on a planetary scale. It is a quest that takes us from the deepest parts of the Earth to the formation of the Moon, and it highlights how much we still have to learn. The idea of a missing part of our world isn't a flaw in our knowledge, but an exciting opportunity for discovery. It reminds us that Earth is not a static ball of rock, but a living, breathing system with a hidden, dramatic history. The clues are buried deep, and it's our job to dig them up. The solution to the missing mantle paradox will undoubtedly rewrite our understanding of how planets form, how they evolve, and what truly lies beneath our feet. The next time you see a volcano on the news or think about the ground shifting beneath you, remember this deep mystery. You're living on top of a giant puzzle, and the biggest pieces are still waiting to be found. Thank you so much for joining me on this journey into the heart of our planet. If you found this as fascinating as I do, please hit that like button and subscribe to the channel for more deep dives into the mysteries of our universe. And I'd love to hear your thoughts in the comments below. Do you think the blobs are ancient crust, or the remains of the planet Theia? Let me know. Thanks again for watching, and I'll see you in the next video.